So who had the question? Okay. There you go.
So I'm studying with a guy, and he had a question for me. And the church that he goes to, he's like, seems like everything they say is like consistent with what the Bible says. You know, that's what they go with, but except for immersion. He's like, and I'm just wondering, you know, like why doesn't everyone believe just what it says? Because it's so simple. Like, why is it that this is where they deviate? And so I gave him an answer, and but I'm just curious to what you would have said.
Yeah. Well, I would have probably said plenty. Yeah, and there's a war for the souls of men. And Satan is at work. If you turn to Ephesians chapter 2. See, if it was just people, okay, some things wouldn't turn out the way they do. Okay? So I'll let you know there's something more than just people involved. In Ephesians chapter 2, in verse 1, he says, "You were dead in your trespasses and sins, in which you formerly walked according to the course of this world, according to the prince of the power of the air, of the spirit that's now working in the sons of disobedience." So, man has enough trouble with the lust of the flesh and the lust of the mind, but there's the additional force of Satan himself. And in 2 Corinthians chapter 4, in verses 3 and 4, 2 Corinthians 4, 3 and 4, it says, "Even if our gospel is veiled, it is veiled to those who are perishing, in whose case the God of this world, that's Satan, has blinded the minds of the unbelieving, so that they might not see the light of the gospel of the glory of Christ, who is the image of God." So you've got Satan actually working inside people's skulls, which is why, when people can reason correctly about other things, when it comes to salvation, their brain goes off into the stratosphere somewhere. I see it with the Institute for Creation Research guys. They just flat make it plain. If you see any of the acts and facts out there, they make it pretty plain that their goal is to glorify Jesus Christ and the Creator, the Savior, and they get a lot of things right until it turns to salvation. So how come all of a sudden their brain quits? They're logic. We have to be logical. We have to look at the facts. We can't listen to the guys that got the big megaphone. We got to go with the facts. Okay, and then we get to Acts 2:38, and the brain went off in the stratosphere. Now, if you're Satan, what do you want? Well, you do not want people to be in Christ. So since immersion is the point at which a person enters into Christ, Satan's got every major battlement and defense possible right there. Every war that's fought, every theological battle that's engaged in, every issue of government is all part of the war trying to keep people away from Acts 2:38. Now, once people do get Acts 2:38 correct, at least as far as forgiveness of sins, then the Satan wants to try to stop them at the next step. He wants to keep them losers rather than winners. So then he's trying to deny the stuff connect with the new creation and the gospel of glory. But the big block is Acts 2:38, and the explanation is that's where Satan is working hard. So even C.S. Lewis, how many of you here have ever read the Screw Tape Letters? Okay, so he's talking about the demonic forces trying to keep this guy, from getting it right. And you can see that it's probably not too far fetched. Okay, but C.S. Lewis said that he was going to leave baptism and communion for the Church of England to decide. See, that's typical how when it gets right down to it, it's like, boom. So, further comments there, Mr. Matthew? That's good. Okay. Other questions or comments here this morning? Caden. That was an excellent opening, by the way. Pretty good impromptu presentation.
Thank you. So I saw something the other day, and this might be a silly question, but I just want your insight. So I think when it comes to like creation science and a lot of the studies in there, they talk about how the different like massive ravines like the Grand Canyon and crazy mountain formations are evidence of the flood. I heard somebody say once that, well, how is that true? Because you see ravines and mountains and different type of, geography on other planets in the solar system. So how does that work? Maybe, yeah, just curious, how does that work?
Yeah. Well, we don't have a lot of information on Mars or Venus as to what might have caused any of their surface geography, but we do have plenty on Earth because it's at hand. Okay. Now, some of you guys remember when we were doing some presentations on a university campus. You remember the night that Dr. Feely came? Yeah. Okay. And so what we were doing that night, we were showing the Mount St. Helens, VHS, and talking about how the massive mud flows that occurred in connection with the volcanic eruption, and then the next, some say volcanic eruptions and coupled with snowmelt, actually carved miniature. By miniature I say 600 feet deep, Grand Canyons down through the previously existing sediment. And what was interesting about it, was that the sediment that got carved through was in layers. So if you were looking at it, you would think that this layer was laid down, this layer was laid down, and this layer was laid down, and this one, okay? But, they actually knew that it came in as one massive mud flow, and that the layers formed due to what are called the hydraulics in the fluid flow, all right? And so the point that they were making is, this would be an explanation for the layers of the earth, that they came in, say, in massive mud flows, okay? And I'll give you an example. If you ever go through Wolf Creek Canyon, okay, now that's all what's called Precambrian rock. I'm pretty sure that was formed during the flood, early stages of the flood, but it's in layers. See, and what's interesting to me about it is you'll see a whole layers, but there's one crystal plane. See, one plane. Now, when you got one plane, that lets you know that crystal formed all at once. Okay, but there's lots of layers in that same crystal. See, that lets you know that that's that type of fluid flow, where it's coming in one mud flow, but it's separating into layers because of the hydraulics in it. So, Dr. Feely, of course, was, he was pretty rude, actually. He was the best. Some of the students came up afterwards and apologized to me for his behavior. But I remember one student asked me, they said, do you have any evidence for the rapid formation of the sediment? Okay, see, you had a kid that was listening, okay? And my answer was the Little Colorado River Canyon, where it comes into the Grand Canyon. A couple years ago when Katie and I were meandering through that area, I made sure we stopped at the Little Colorado. You remember that? Because you're standing there and you're looking 1,000, 1,500 feet down, straight down. Okay? But it's a canyon that meanders like that, straight down. Now, there's only one way that you're going to get a canyon vertical walls that deep, and that is if all that sediment is soft. See, if that sediment was hard, like it is now, and you get erosion, it's going to be a lot wider V. See, it's the only way you get a vertical canyon like that the meander just helps seal the case, so to speak, because the original river, what was the Little Colorado, was actually joining the main Colorado up here. Then whatever caused the main Colorado to drop and form the the Grand Canyon, then here's a little Colorado up here, and here's the main Colorado thousands of feet below. So what has to happen? Well, the little Colorado's got to carve down to meet the main Colorado. And the fact that it carved straight down for thousands of feet means that that sediment was all soft. Now what that means is all that sediment was deposited rapidly in the flood, and that in the post-flood things that happened, then it was still soft enough to carve straight down. That's the evidence that I had for rapid sedimentation. So, Caden, when we're looking, at things like the earth, okay, and what do the canyons prove? They prove, actually, it had to be a flood. It proved that the sedimentation was deposited during the flood, and that the immediate post-flood erosion is what basically left us with our current landscape. And so that's why that's important as far as the ICR and answers in Genesis and stuff is concerned. Further comments there, sir? Other questions today? No.
You left out one important part on the Mount St. Helens erosion thing. They were expecting the mountain to explode or erupt, and they had planted movie cameras around its particular spots and obviously well anchored them. They've actually got film of the layers coming down literally in a matter of seconds from one layer to the other. And I'd have to say, my opinion of it would be the difference in the viscosity of this material that is being laid down. They have different weights, so they're going to have different speeds, and they're going to be grouped together. And because the wind that was created by the explosion was enough to knock down trees miles away. That was the kind of wind. But the camera stayed up in the background. I mean, they got it on film.
Yeah, they do. And there are two types of layers being formed that day. There was the wind layers, and then there was the stuff from the water. See, because you had two different, so that's why, the Toutle River and the Cowlitz got plugged, and they spent, I think Brian Kerr even spent a couple years up there working on dredging those channels. So you actually had the wind, pushing all that, and then you had the water due to the snowmelt. So you actually had two different sets of sedimentation being formed, one by the wind, one by the water. And both of those are important. When it's wind driven, it has the name LOESS. Okay? And for example, in the United States, there's wind driven sediments in the United States that came from China. So when Mount St. Helens blew up, see, among other things, I remember we were in Moscow, Idaho. We were studying Marshall Scatone in the gas station there. Paul remembers that. And Luke and Matt were playing in the ash from Mount St. Helens out in front. They were playing trucks or whatever they were doing. And but that ash there was like, 4 to 6 inches deep. By the time it tried to get over the Continental Divide here, it was a lot thinner. Okay, but only 1 cubic mile of mountain blew up when Mount St. Helens went up, which caused dust. You got ash 4 to 6 inches deep in Moscow, Idaho, from Mount St. Helens over on the west side of Oregon. See, that's a lot. Think of all that area. That's one cubic mile. What mountain was at West Yellowstone, or when Yellowstone Park blew up, that was like 4 cubic miles. And there's ash. That's again wind driven. Ash 4 feet deep in places of Nebraska. See, from that. And see, it's hard for us to process the scale of things that happened during the flood. Very difficult for us. So, but the wind-driven stuff, it does separate into layers just like that. And the water-driven stuff, and like Mel points out, it has different viscosity. The windows that you look through, those are actually liquid. Those are liquid. They are. And it's just got a high viscosity, and it flows real slowly. So you take an old miner's building, okay, the windows, if they're still there, will be thicker at the bottom than the top because it's been flowing. But that's high viscosity. See, honey has got a higher viscosity than water. Water is the standard viscosity. Water is a standard of 1. Everything is measured, compared to water. But when you have fluid flow, whether it's air or, say liquid driven, there's always viscosity issues, and that is going to separate it into layers, just like Mel was talking about. And that's what you see on the surface of the earth. You got a deposit of wind-driven stuff. It's going to be in layers. Came in all at the same time, but it's going to be in layers. It's going to look like this layer came in, this layer, but it didn't. It was coming in in different viscosities. See, and that's, these guys, in MSU, these guys are scientists. You go over in the engineering department, they know all about viscosity. Yeah, you had to study viscosity.
I just told her this is junior level chemical engineering class.
Yeah, junior level. See, it's not even senior level, or grad level. But, you have to study this stuff because, if you're out there in industry, that's what you're working with. And so it's coming in, and they know that. But their brain goes off. See, like we were talking earlier, they got the same problem with an evolutionary viewpoint. See, as soon as their brain has to turn off as soon as they start looking at something that would point to the flood, because they recognize if they go there, then their whole evolutionary deal is gone, and their whole ability to get grants from the federal government is gone. And believe me, that is a major factor. And so a lot of things at work blind in the minds of the unbelieving. So, further, did I cover that one, Mel? Adequately? Yeah, it's great. I mean, those are important things. Nick.
I want to go back to your Colorado River, Little Colorado.
Yeah.
But before, I remember as a kid, we lived in Columbia Falls, Montana when that blew, and I remember playing in the ash up there. What I didn't realize is when we were in Portland had no ash. That's how hard it blew. Just blew it right up the top and clear into Idaho and Montana, but none in Oregon, or not much.
Yeah, it's because the prevailing wind is from the west. See, and so as soon as it went up in the air, which then pretty much took it east. Yeah.
So my question about the Little Colorado is if that was soft and it dug it that deep that fast, it also had to have hardened relatively fast too to preserve it. Otherwise, it would have eroded into a big V.
Yep.
Right?
Yep, exactly.
So what is it, the wind in, or what would have caused that much sediment to get that hard that fast?
Yeah. Well, I know, Nick, you're being in the construction business, you're familiar with concrete. Okay? And, concrete, special mixture. They bring the sand and the lime and, together, certain chemicals. And then, but they mix them, say at the plant, for example, and then they keep that going so it doesn't set. And you see, I'm totally amazed at the concrete pumps we got now. I mean, I'm sitting there watching those guys pump 4 or 5 stories high if they need to. I can't even believe it. We remember when there weren't concrete pumps, and these guys that shovel, trying to get it on the conveyor belt, trying to get it up the second floor or something like that. But concrete sets, and within about a day or two, it's set, right? Okay, and it's a chemical reaction. Okay, same things happen with the sediment. See, there's certain chemicals in there, depending on the sediment. It's going to set, and it's going to set pretty fast, once it moves into the stage where it sets. Okay, even that deep. Yeah, because it's chemical. It doesn't have anything to do with exposure to air. It has to do with the chemical reaction that's going to take place. And when I was in college, between my sophomore and junior year, I had a job in Las Vegas for a Dow Chemical Company actually Stauffer Chemical Company in Vegas. And I wasn't a Christian at the time, so the weekend was totally free. Okay? And so west of Las Vegas, there's something called Red Rock Canyon. And so it's kind of a state park or something now, or a national monument or something, but those days it wasn't. And at the edge of that was a sandstone quarry. And so, I just looked it over. Well, after I became a Christian, I went back to Red Rock Canyon to look at it. And because now I'm looking at the same thing with a different set of eyes, okay? So you have this gray-colored sandstone, but in the middle of one of the sections in the quarry, there is a huge bubble of colored material. And it went through a lot of layers, but it was a bubble. You could tell what happened is that, you get, some glorp of something dropped in there, and then it sets, okay? So the sandstone came in place, the bubble stuff was trapped, then the sandstone had time to set. Boom! And of course, sandstone, a lot of times when it sets like that, is hard stuff. And so it's chemical reactions that cause it. And it can happen, the chemical reaction can happen fairly fast. So, you could be talking probably a couple weeks, maybe a couple months, depending on how, the particular chemicals. And I like to point out that on the pass east of Bozeman, okay, when the 2-lane went through there, they didn't make a cut in the hill. But when they put the interstate through, they shave that hill off on the north side. And so you'll notice if you're driving east and you're looking left, you're supposed to be driving, but you're actually looking over here. And okay, you'll see these hard rock layers of sandstone. But right in the middle of it, you'll see about a 3-foot layer of nothing but sand. Just sand. Okay? See, what happened there, Nick, is it didn't have the chemicals in it to enable it to set like concrete. And that's why, those things form like they do. It takes a while, and it's going to depend on particularly what type of chemicals are in that particular batch of sediment. But that's how the shales form. That's how the sandstone forms. Limestone is purely chemical. Limestone forms today, off the island of Bermuda. If the air pressure changes, limestone will form and the limestone will go away. Because what limestone is calcium carbonate. It's called hard water, and that's what you try to keep from building up around your faucet, okay? And if you don't get there quick enough, then you're with a chisel or something like that, because you're chiseling limestone off your sink is what you're doing, okay? That's hard water. That's calcium carbonate. And calcium carbonate will form on a massive scale when you have a change in air pressure. The chemistry is a little bit involved, but what happens so you got the calcium ions floating around in the water, and you have carbonate, that's carbon, essentially it's dissolved carbon dioxide is what it is. And so you got the calcium ions floating around, and you got the carbonate atoms floating around, ions floating around. And if you have a change in pressure, that will change how much of it can be dissolved. When you have that change in pressure, boom, you'll have instant. If it's enough change in pressure and you got the flood type conditions where you have a lot of dissolved carbonate, calcium carbonate, boom, you'll get the massive layers of limestone like we see. See, it's chemical again. See, and it hits and it's soft, but it hardens really fast. The Quake Lake, where, remember a chunk of mountain broke loose on the south side, and it piled it all on the north side, and there's a couple big rocks right at the top. Okay, the big rocks there are dolomite, and the dolomite is magnesium carbonate. See, and so a lot of times you'll have calcium carbonate and you'll have magnesium carbonate form at the same time. Or sometimes it'll be a combination of calcium, magnesium carbonate, which gives you various materials. See, but magnesium is just, it's in the same line as carbon is, so calcium, so it has a lot of the same chemical characteristics. So these things form under flood conditions. Another one, if you have geodes, okay, how many have seen geodes? Okay, they're hollow on the inside. What those were dissolved silica. See, there was enough going on in the floodwaters and the temperature and everything else that silicon dioxide would actually dissolve in the water in a major way. Okay? And then as those things are precipitating out, what you would get is you'd get a ball of silicon dioxide, rolling. Of course, when it sets, it forms a rock, because that's what pure silicon dioxide is quartz. Or maybe I put it this way, pure quartz is pure silicon dioxide. And so what happens is you have these globules of silicon dioxide, and so in the Ruby River, south of Sheridan, there's all kinds of those geodes out there in the ground all over the place because that's how it forms. See, so basic point I'm driving at is the flood conditions were such that on a scale, when you compare man to the flood, man's not very big. And the types of things that were going on were on a chemical, water, everything else type of scale. What wind, we can't even process. Some of you guys were in Oregon. How many got to go to the coast while you're there? Okay. How about some of those big dunes? The current stuff coming off the Pacific Ocean didn't produce those dunes. See, that's all part of the post-flood, immediate post-flood stuff. How many ever seen the dunes at, say, Alamosa, Colorado? Okay. They're all over on the east side, aren't they, Charlie? Yeah. See, you can tell what happened was that the post-flood wind was blowing really hard, and that was you can tell it was an old lake, is what it was, right? And then it drained out. The Rio Grande drains through, but one of the other rivers, it just goes there and dies. But you can tell what happened. See, in the post-flood, you still had these massive wind events on a much bigger scale than we have now, and it's pushed all that sand off the bottom of that lake and shoved it over against the Sangre de Cristo. Same thing over at Ashton. How many ever seen the Ashton Dunes or St. Anthony Dunes? The same thing. You can tell there it was just, except the wind was coming from the south there, pushed those dunes up. Okay, we don't have that stuff happening now. See, it's post-flood. It's a scale. The problem is the scale is so big that the geologist can't process it. And I used to have a sign hanging over here in the math department, but I think had some rebellion, so it's been taken down. But, I think it's in our bedroom now someplace. Hidden. But I had it made because I was thinking about some of this stuff. I made a frame, and then this frame inside a frame, frame inside, after about 10 frames, in 6-point type, okay? Cliff knows how big 6-point type is. I had these words: you think too small. See? To try to illustrate the fact that when they're looking at things, they're thinking way too small. They can't see a big enough picture. No?
I mentioned it before, but I'll do it again. Several years ago, we went on a jet boat ride on the Colorado, and we went by this grain elevator that's alongside the river, but it wasn't a grain elevator. It was the top of a mine where they were bringing up potash.
Yep.
They claimed that the potash down there, 5 miles thick.
Yep.
And radiated out 90 miles.
Uh-huh.
We can't even think. I mean, that's impossible depths and calculations.
Yeah.
Now, the environmentalists, complain about the cracking of the oil that's down 5 miles, and they say it's going to pollute the surface water 5 miles down.
Yeah.
No way.
No.
There's no water down there. There's oil down there.
Yeah. It's pretty interesting when you start really, again, examining what's there. The potash deposits, the various, potash is basically a potassium salt. And but a lot of those things form in connection with the flood and the post-flood. Salts, whether it's rock salt or the potassium salts, those tend to form a lot of times where you have a rift, some sort of a volcanic rift. For example, the Dead Sea itself is 2,000 feet deep, but the Dead Sea is sitting on 10,000 feet of salt. See, that's part of, that's part of the events that were going on. If we go back to Genesis, Genesis gives you just enough to get you curious. Maybe it was designed to do that. But when he starts talking about the flood, of course, Noah got the ark built, and then God closed the door of the ark. Okay, God shut it. That means that Noah, even if he wants to, he can't open it, okay? And so in verse 11, Genesis 7:11, that's 7:11. That's good. It was more than the roll of a dice, I guarantee you that. Genesis 7:11, in the 600th year of Noah's life, in the 2nd month, on the 17th day of the month, he's got this pretty precise, doesn't he? On the same day, all the fountains, it's interesting, same day, all the fountains of the great deep burst open, and the floodgates of the sky were open. See, so two things are happening. You happen to having a major 40-day rain event, okay? When, was it? Hurricane, I can't remember which hurricane it was. It hit Houston here some years back, and it just sat there for about 3 days. And Houston ended up with over 50 inches of rain. Okay? That was a 3-day rain event. 40-day rain event. But that wasn't all. See, the floodgates of the deep opened as well. See, so we just get basically a one-liner in the scripture as to the events that triggered the flood. Okay? It's looking at what we got now and looking back at it, see, honestly, to try to see what happened. The evolutionary guys, they're not willing to even take a look at honestly what happened. They're not going to see it. And they don't want to see it. Now, when I was in high school and college, I studied a lot of geology, something I was interested in. And I did take a geology course on the university campus, but I already knew everything in that one. But because you can get a lot by reading, you don't have to go to college to learn stuff. Just start reading. You can find all kinds of stuff. But everything I read talked about the vast inland seas in Montana, and in periods of orogeny. See, they throw words like that, orogeny. Okay, that's just mountains being lifted up. Okay, but see, it sounds pretty intellectual if you say orogeny, right? Orogeny zone. Okay. Slow processes. Millions of years of slow sedimentation. Okay, that's not what you see, actually. That's what I saw when I was looking at it through the lens of that education. See, but, I did have questions. But see, once I recognized the existence of flood, everything made sense. Everything made sense. And, it's really interesting, again, how short-sighted the geologists are. I was taking a little time yesterday to, look at the, last week I had a picture of Beaverhead Rock, or maybe the week before. And so I was going back and looking at the geology behind that. And it is really interesting because these guys, they know what they see, okay? So they're telling you, okay, there's 7,000 feet of such and such sediment here. And 14,000 feet of such and such sediment here. See, and they give them names, like the Lima group, okay, or Red Mountain Conglomerate or whatever. They give them names, but they can't see that they're all connected. See, they've got them broken up so that they don't match the Flathead sandstone of Montana with the Tapete sandstone or with the painted rocks of Lake Superior. Same sandstone. See? They don't put them together, but they're the same. Okay, see, so Arizona to Montana to Michigan, I would say that would be pretty I don't think that's going to be slow sedimentation in a western sea. See, that's continent wide. And actually, it goes into Europe, it goes into South America, and they're working on Asia and Africa. And they're working on Asia and a lot of Europe right now. But it's, okay, they can't see it. They're thinking too small. See, it says all. It said all. Okay, this massive. Bill?
I mentioned about the oil about down there at 5,000 feet. Okay, what is that oil? That oil is plant life. Now, how did that plant life get down 5,000 feet?
Yeah. A lot of places they're like dwelling 12,000 or even deeper, See, and that's a great question. How did it get there? It's pretty clear. It's part of the flood. Some of your early oils and your eastern coal are a result of the earlier stages. Your western oil and your western coal are a result of the later stages of the flood. Okay? And so the coals are different, for example, and the oils are different. But they're all flood related.
I'm not sure who was talking about this either a few weeks ago or whatever. It was either you or Phil, I think. We're talking about uniformitarianism. So when you have like NASA looking for life on Mars and looking for signs of liquid water and so on and so forth, if Mars is going to have liquid water, it'd be my expectation that you couldn't have life on Earth at the same time because it'd be too hot, correct? Okay. Also, when you have, because they believe that everything happened, uniformly. Now, with the sun, it's constantly losing mass as it's burning. So if you roll the clock backwards, in order to have, say, life on water on Mars, the gravitational force is also going to increase, correct, as the mass of the sun? Yeah, because the Earth and Mars and Mercury aren't going to change mass, but the sun is. So how do they explain that, or maybe they don't explain it, but how they deal with that if it's truly uniformitarianism, and how they deal with concurrent life on Mars and possible concurrent life on Earth, and then the gravitational force of the sun?
Yeah. Well, one of the ways of dealing with inconvenient facts is to ignore them. Because, the sun is obviously basically fuel, where you have hydrogen being converted to helium by compressing process fusion, compressing 4 hydrogen atoms together to make 1 helium atom. Now, not all that helium's even staying on the sun. There's what they call a solar wind, which is helium atoms flowing from the sun at the rate of 250 to 650 miles per second. Okay, when you see the comets, if you saw the comet, what was it, last summer? Or last spring, whenever it was. Okay, that comet tail pointed away from the sun. And the reason the comet tail points away from the sun is because of the solar wind. That's helium. Okay, so you got not only the shrinkage connected with the sun, just the hydrogen atoms being compressed to one helium atom. You're losing mass, size in that process, but you also have the helium atoms making their exit. Now, if that's been going on very long, the sun's going to be way too big. It wouldn't have been many millions of years back there that the sun would have been so big that it would have actually absorbed the Mercury orbit. Okay, so an honest, objective look at that is say this is only a couple thousand years old, maybe 10,000 at the max. See, that's the actual fact. So same way, the reason they're looking for water is they recognize that all life has to be carbon-based, okay? The next nearest atom that would work is silicon. Silicon forms long chains, but the trouble is silicon is rock, which isn't very lifelike. So the only atom that's going to work for life is carbon. You can't change the characteristics of the elements just because you go out to Pluto or Alpha Centauri or something, So you have to have a carbon-based life. Well, carbon-based life is going to have to ride on liquid water. Okay, that's how it works. So you're going to have a planet with water in order to support life. And they actually have a name for it. It's called a terrestrial planet. Okay, that terrestrial has to do with Earth. Okay, the Mediterranean Sea, see the Terra in the middle of it? That's Earth. So the Mediterranean is actually Middle Earth for all you fans. Okay, but see, terrestrial has to do with Earth. See, because they recognize that Earth is the only place, a planet like Earth is the only place that will support life. So all those billions of dollars, trillions of dollars, the taxpayers' money, NASA's specific goal is to find life elsewhere. And it is totally amazing. We were talking about how the God of this world blinds the minds of the unbelieving. Okay, they're looking for life elsewhere, but they can't figure out that DNA had to be God designed. See, looking way out here, can't figure out DNA had to be God designed. See, but that's all part of the way Satan gets people's thinking twisted for whatever reason. See, and so these things impact our ability to spread the gospel and our ability to communicate to the people around us. See, and so God, you can't. Obviously, not everybody can be an expert on everything. So some of you guys need to, become experts in, say, geology. Some of you guys need to become experts in, say, the origin of languages. Some of you guys need to become experts in archaeology. Because sooner or later it's going to take the body of Christ working together to fight off the massive confusion that they got coming at us. Because make no mistake about it, their goal is satanic, and the goal is to prevent people from believing the Bible. Like Caden was talking about, you got to believe the message first before you believe in the author of the message. And so the goal is to destroy the credibility of the message by lies. And the Bible says Satan is a liar, and he's the father of lies. So where all these lies are originating is Satan. And so it's a tremendous battle. See, the battle for the soul is absolutely tremendous, and it's intense. And that's sometimes something we have a hard time processing. Is number one, how intense the battle is for our own souls. And secondly, how intense the battle is for our brother or sister of Christ, and how intense the battle is for the people we're working with. This is no holds barred. I think of those physical battles that they used to have, where the armies went into the field and started mowing, each other down. Some of David's mighty men, the guy could stand in the middle of a lentil field and wipe out 600 people, one guy. When they got done he couldn't get his hand off off his sword. They had to pry his hand loose, okay? But that's a great picture of the physical intensity. That's designed, recorded by God, to help us understand how intense the battle is spiritually for each one of us. You can't see it, see, which tends to lull people to sleep. But that same battle is absolutely intense, and it's raging for the soul of each one of us in this room. It's raging for the soul of the other members of the congregation. It's raging for the souls of our neighbors. It's a tremendous, tremendous battle. And that's why, God really wants us to be Christian soldiers and endure the hardship, is the way Paul put it to Timothy, because of the intensity and the seriousness of the battle. An individual loses that battle, what happens to him eternally? Hell. See, and you and I need to face that. People at the end of the line are going to end up in heaven or hell. That's it. So whose side are we on?